So Eli, without further ado, I'll let you take the reins. Thank you so much.
Thank you very much, Sean, and thank you for inviting me to participate in this session. It's been always a great success talking to peers and leaders in the industry. Most of the great ideas are coming actually through a multidisciplinary approach, hence having an audience that comes from different backgrounds and different industries helps a lot. Throughout my career, I've been to several industries, including software, financial data, and storage systems, and aircraft simulation and such and such. So I think that given the variety of our backgrounds, first and foremost, I would like everyone to keep in mind and ask themselves the question of what is actually we are trying to get out of a particular project. Is it a research project, or is it something that we envision to be deployed in production and act as a true production grade system that will get a dollar valued ROI? Okay, and in terms of AI, I will be playing a Captain Obvious role here during the presentation, and that this is something that many times in many corporations and at the highest level, folks tend to kind of omit and follow the buzzwords. So I'm a practitioner. I like to see why we're doing something and to put hard dollars behind the effort. Unless it's a pure research effort and we need to burn some cash. Otherwise, we will not be allocated that budget for the next year. So as a practitioner, I'd like to kind of walk through a typical AI readiness, and it all starts from infrastructure. What kind of infrastructure we are going to be running on? Running on fully cloud infrastructure is one thing. Running on hybrid infrastructure is another thing. Running on-prem infrastructure is completely different thing. That will require a different type of talent, that will require a different type of effort, that will require a different level of engagement with various teams through a company. Whether, you know, if it's a startup, that's one thing. If you're an educational institution, that's another thing. Depends on the level of security, depends on the data domain. The effort might be from days to months, right? So we need to recognize the difference of our domain and the difference of our environment, right? So if we start from infrastructure, we actually start thinking about Maslow, the pyramid of Maslow, the hierarchy of needs, right? The infrastructure is the very, very fundamental stuff, which implies if you're running on-prem, we would need a certain type of hardware, a certain type of software stack. Someone would need to manage that software stack for you. And then before even we engage in the data business, we need to iron these things out. Most modern companies start with very straightforward, you know, a lot of use cases in the marketing and advertisement business are quite straightforward and quite simple. You aggregate data from many different sources across data providers, and it's typically marketing data, and it's typically clicking and impressions and all the good stuff that comes with it. And your environment is completely cloud environment. So these are type of the projects that are really solve problem, right? So this is something that we're not discussing here. I hope, unless someone has a lot of questions in that respect, I'll be glad to hear those ones. But I think that more importantly is what the participants today would love to hear is how you get an enterprise going through an AI readiness cycle. And with that, I'd like to kind of start a brief survey of what kind of outputs or what kind of expectations do you have from your AI, any AI project? Is it pure research, or you would expect a production grade system ready? If you don't mind, guys, kind of share your experiences. don't necessarily expect to hear any details about the projects, or definitely nothing proprietary or proprietary nature. But it would be great to hear what types of AI projects are out there, and start from there.
And Jane asked, do you have a template that you could provide to set up a process to design?
So I have a template, but it would be a great thing to put together, something that I might attempt to do when I have a couple of hours on the weekend. But yes, if this is something that you would be interested in, I'll probably make an effort and put that template into place. And I'm sure you guys did some prior literature research. If we Google long enough, I'm sure there are a couple of templates out there. Let's try and briefly walk through a template right now, so that we're all on the same page in terms of what are the main steps. So we've mentioned the very base layer of the hierarchy of needs, and this is typically the infrastructure, right? The storage and the software stack. Now, in terms of going into the next level, that's your data collection layer, right? So if we are talking about data collection, that means we need to put the pipes and, speaking in plumbing languages, all the faucets, all the pipes should be there. We need to apply, whether we are getting data periodically on an hourly basis, on real-time data, it's a completely different software stack. The next layer would be the outlier and cleansing and anomaly detection. Like, we need to prep our data for the analysis, right? Then we would need to aggregate it and label it and do some basic metrics to learn what we have there. And only then we will proceed to A/B training. We will then proceed to deep learning and AI, which is the top of the algorithm. There's a very famous hierarchy of needs in data science area, that if you Google data science hierarchy of needs, you'll get this nice representation of what we are talking about. But basically, if you start from the infrastructure, right, you need to get your instrumentation, you need to sensors, logging, vendors. Later on, if you think of good AI, you would need tons of data. By tons of data, I don't mean something that you can open up in Excel. I don't even think that you can open something in a text editor. We're talking about terabytes and terabytes of data. Hence, you'd probably need tools like Spark. This is a computational engine. You'd probably need a good amount of PySpark notebooks to interact with your data. Or if you're at later stages, you'd probably need to load your data into some sort of warehouse like Redshift or Snowflake, or any column-oriented or big data stack database, right? So that you can actually query and interact with your data. So this is something that is, again, very important. Once you have set up the infrastructure, you have set up the software stack, that how you're going to facilitate the mechanics of interacting with the data. That's going to be your ad hoc exploration. That's where your cleaning and anomaly detection and prep starts. Then with the same tools, you can do metrics and aggregates and features and kind of training data sets. And only then you can do the A/B testing and experimentation, right? So running something very simple, there are for simple ML algorithms, there are a gazillion of libraries today that you can go through. Very important aspect in any of these projects is failing fast. So it's rather not seeing that not going to the phase of we got something working, but finding out what's not working, like finding out stuff that can prevent you from getting where you're going, right? So finding these obstacles early in the process is very important from the time perspective, right? So we'd rather see something that is very quick and iterative in your process. That's going to be a much better approach than waterfall, right, or top down. So okay, I see that there are a couple of questions in the chat. Predicting college student retention, fall to spring or fall to fall using demographic and academic variables. Perfect example, great example. Something that you can probably use open data. The data is probably available if you collected it within the institution, or would you like to do this across various institutions? That's going to be a more interesting project. AI initiatives on data analytics projects. Okay. Okay, someone says, Tanvir, thank you. Data is critical to speed. Speed is an essence of any transformation initiatives. Correct. Correct. You want to fail fast. You don't want to fail. You want to fail fast, right? So in terms of practicalities and in terms of putting dollar value into that. So that is something, again, that is often omitted, but asking the hard questions. We are going to spend that amount of dollars. We need to be prepared that we find out that this doesn't work. The idea did not work. So in the beginning of every AI project, we must have a hypothesis. Proving or disproving the hypothesis is one of the outcomes of any AI project, right? So having a hypothesis formed well and putting the dollar value. So if this works, if A works, then we are getting an ROI of X amount of dollars is very important while we spend such and such amount of dollars, right? Which is both infrastructure and labor. And most of these projects are very labor intensive. All right, we have a question. What are some of the implications of second wave AI and deep learning, in my opinion? The implications of second wave AI is that I think folks realized that we have a bunch of problems already solved in various industries. So the second AI wave attempts, in my way, to address harder, more open-ended problems like interacting with clients. So, second level is the first level is solved. We all see that we can interact with any chat bots or support bots to achieve a certain level of responsiveness. The implications of the second wave, I think that the industry will attempt to tackle more complicated projects as handling open-ended conversations, or more towards general AI, which is very hard problem to solve. Another implications is that we are attempting to solve, speaking statistically, we're attempting to solve the 0.02% of cases that are very hard to solve. Think of self-driving cars, think of Waymo, and think of what they do with trajectory planning, right? So trajectory planning is the part of the mission computer in a self-driving car, or autonomous car as they like to call them, that given all the inputs about the environment and giving all the projections about the objects within that environment, we try to plan the trajectory of the vehicle, of the car. And so given 99.98% of cases, this problem is very much solved. What we are solving for is for the edge cases, right? Which is something that AI has still a lot of trouble solving, simply because it requires a lot of data and millions and millions of miles driven, right? So I'm using this as an example of how can you improve your last couple of percent or last fraction of a percent. That margin is always the hardest. You start with 80-20, right? I'm going to get good enough. In many cases in chatbots, there is no life critical situations, whereas with driving with autonomous cars, there is a certain amount of liability that they possess that they need to solve for all cases. So getting these last 2% or last 0.02% is very hard. And the implication is that we are going to collect more and more data, hoping that it will provide sufficient coverage for us to train the algorithms. This is the implication.
Should you include as much data you can to your data lake so it's available for later analysis? Or what's a good methodology to identify critical info?
That's $1 million question. It is $1 million question. So Jamie, this is something that that can be a great interview question for a data scientist. Given 1,000 data sets, how would you identify those data sets who would bring additional value or find your alpha or find the edge? In my opinion, I think you should include as much data as you can, as long as it's probably labeled and the metadata that you collect on these data sets is uniform across everything that you store. Because what's going to happen if you store without the proper metadata or proper tagging, later on, it's practically impossible to identify what the data is good for and whether the data is going to solve the problem that we attempt to solve. So this is where, so if you think about labor-intensive tasks, attempting to find out if a particular data set brings value or subtracts value from the overall project is where the cost is, where a lot of cost is hidden. So that if your protocol for collecting metadata is the same and universal for all data sets, then great, store it, because you will be able to quickly assess whether the data adds value or not later on. Now, in terms of good methodology to identify critical info, that's something that a taxonomy of your domain will tell you. So if you think of Wikipedia, right, and you think of a taxonomy of any entity, you can clearly see how you can move on ontology, right, of the terms. If you can come up with a good series of terms and try to fit most, I will not say everything, into that framework, then most likely you'll be successful. Because typically having that metadata stored helps a lot. Also having descriptive fields like I'll bring an example from financial industry that I'm familiar. If you're talking about financial data, or any financial data set, you probably will be looking into what are the asset classes covered. Are these futures? Are these equities, bonds, fixed income, over-the-counter traded instruments? What is the universe, right, of the markets covered? What are the regions? Is it European data, US data, South America, North America? What are the related data sets, right? So not only the data set in itself, but also relation to other data sets, right? So think of knowledge graph that Google built. If you're searching for this, then you'll be probably interested in that, right? So relations to other data sets is important. Sorry. So that's very critical info, but this metadata is your key, is your guidance to what you store.
Thanks, Eli. We have another question. So when digital transformation is solely the responsibility of IT and the business units are not directly engaged, the focus from business outcome shifts to the technological benefits. How would we rationalize this approach and steer their transformation programs to succeed at the enterprise level?
Thank you, Sean. I think that I will restate the question. That's okay for being too wordy, but the digital transformation cannot be sole IT responsibility. In fact, I would argue the other way around. The digital transformation has to come from business. It absolutely must be business-driven business initiative, because IT in many places is just a tool for achieving business outcome. And it cannot be, I don't mean it in an offensive term, IT has to digitally transform itself. Okay, there are projects that are of a digital transformation within the IT department, means how IT is being managed, because IT is a business, right? So instead of requesting multiple budget increases, we can take a look at how IT can function better. But that's an IT business. That's being in IT business. The core business or the revenue bringing, right? So we look at two aspects here. We look at who is bringing the revenue. If it's IT company and we sell IT services, then naturally this is our core business. But more often than not, it's not the case. In that case, if you don't have business support or you don't have business value, IT cannot lead digital transformation, because business will not see a benefit or why we are trying to do. The push may come from IT. The conversation has to start from CTO. And the best advice that I have heard in years is a question: if someone new started the business today, would they be doing things differently? And if the answer is yes, the likelihood of you being driven out of business in the next 5 to 10 years is very high. Because if someone can come in and start doing business differently from what we are doing today, then we are going to be out of business very soon. Because, you know, given the market efficiency hypothesis and given the fact that if the benefits are clear and obvious, it's going to be there.
How to overcome legacy obstacles within traditional organizations?
It has to start from the top. It has to start from top. There is no other way. There is no way, and I've been in that sort of organizations where they're simply irreparable. They're simply irreparable because the C-level or C executives are wording it as we want the digital transformation, yet on the ground they are not doing anything to facilitate that. More than that, oftentimes they just simply oppose the changes that must be associated with digital transformation. Does that sound familiar to anyone? Let's do a quick survey. Did anyone experience that any initiatives that come from engineering department saying, hey, we need to pilot this and we need to show that, actually meet resistance for anything but the reasonable reasons? Yes, okay. So who has heard about, we cannot do this because of security. We cannot do this because of, yeah, there you go, Kim, perfect. We cannot do this because of liabilities. We cannot do this for legal reasons. So there are a number of areas where engineers are being disarmed very quickly into the process because they don't recognize the duck. Although it walks like a duck, it talks like a duck. and you're going to be steered in various directions, but you will not see any progress despite all your efforts. Leading through these changes times will require a new kind of managerial wisdom, to be honest. Yes, it has to come from the top. Once again, the change or actually understanding only can be brought from external talent, means hiring from big tech companies, hiring from startups, hiring from people who are able to articulate the importance or showing very quick, achieving very quick results with very little. So prototyping, right? Prototyping and doing something very fast on publicly available platforms. And today you can do amazing things on both in the AWS and GCP or Azure. You know, there are tons of libraries that you can prototype very fast. There are tons of reference architectures. If you Google AWS reference architecture, Amazon put a library of, I think, hundreds of use cases, right? So that you don't need to reinvent the wheel. Always try to think that someone already solved the problem. If the problem doesn't look too complicated, probably someone already solved it somewhere.
Thank you for your participation. Eli, this has been really great. Thank you so much.